Hey guys, so here's one about a skydiver and opening a parachute, okay? So you gotta imagine a skydiver just on an airplane. We know when they jump out of the airplane, we know they're accelerating, they're going really, really fast, right? We're going faster, 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 faster. And eventually, as we're going faster, 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 that force of air resistance increases until they become equal. And when we're falling and those forces become equal, when that downward force of gravity pulling me down towards the center of the earth, my weight exactly equals my force of air resistance, those air particles push me up, we know that's when I fall at a constant speed, right? Because the resultant force on me is zero, right? Remember, resultant force is mass times acceleration. There's no resultant force, there's no difference here because the upward and downward arrows are the same size, they're balanced. So the resultant force, the difference is zero, so the acceleration must be zero. So they're not accelerating anymore. They're not getting faster and faster and faster anymore. They're falling at a constant speed. They might be falling like 20 meters per second, right? They're falling at constant speed, like a car driving at a constant speed. Now it says what's going to happen now is they're going to pull out a parachute. So what happens when they pull out a parachute? You know the reason we pull out a parachute is because we want to slow down. Okay, if I want to slow down, if I want to decelerate, there must be an acceleration, right? We're decelerating. We're slowing down, slowing down, slowing down. So there must be a resultant force, okay? So why would I slow down? It's because there must be a bigger force pushing me up than there is pushing me down, right? We can see that there's a bigger force pushing me up. There's a resultant force in that upward direction. So that's why then I'm going to slow down, slow down, slow down. Because if there's a bigger force pulling me down, if it was the reverse, if there's a bigger force pulling me down than pushing me up, in this case, this one we're accelerating, right? We're getting faster and faster and faster in this downward direction. But here, when we open our parachute, there must be a bigger force pushing us up because we're slowing down. So you think, why would there be a bigger force when we open that parachute? There's a bigger force in the parachute because there's a larger surface area, right? Now the air particles can hit all of that area, right? There's a really big surface area. What I'm going to say is, why does her velocity decrease rapidly as the surface area increases when she opens her parachute, right? So what happens when you open your parachute? Her surface area increases. So we know the force of air resistance increases, right? So she used to fall at constant speed. They used to be the same size, but now because she opened a parachute, that force of air resistance has increased. So we can see there is a resultant force upwards. So, is it she or he? So they, we don't know. So they decelerate. They're going to slow down and land safely, hopefully, on the ground.